What if I told you that you are not the main character in your own life story? What if you, in all your complexity, with all your hopes, your fears, and your dreams, are actually just a temporary vehicle, a survival machine, built and controlled by the real protagonists of life on Earth? Your immortal genes? This is the radical, controversial, and brilliant idea at the heart of Richard Dawkins's landmark book, The Selfish Gene. Published in 1976, this book didn't just explain the theory of evolution, it turned our entire perspective on life upside down. It proposed a gene's eye view of the world, a profound and sometimes unsettling shift in our understanding of who we are and why we are here. This is not a story about you, it's the story of the ancient, immortal, and endlessly replicating molecules that built you. But as we'll discover, this seemingly cold and cynical idea is actually the key to understanding some of the most beautiful and hopeful aspects of our existence, from the fierce love of a parent for a child to the very nature of human culture itself. This is a journey to the very foundation of life, to understand the philosophy of the immortal replicators. To understand the gene's eye view, we have to go back to the very beginning, to the primordial soup of early Earth, 4 billion years ago. In this chaotic chemical broth, a remarkable accident occurred, a molecule formed that had the extraordinary ability to make copies of itself. This was the first replicator. In the beginning, this was a slow and clumsy process, but as the replicators copied themselves, errors or mutations would sometimes occur. Some of these errors would make the replicator less stable and it would fall apart. But other errors would, by pure chance, make the replicator better at its job. Maybe it became a little faster at copying itself, or a little more stable, or better at breaking down other molecules for building blocks. These improved replicators would, by definition, become more numerous than the others. This was the dawn of natural selection. Over millions of years, these replicators, which we now know as genes, became more and more sophisticated. They began to compete with each other for resources. And they discovered a revolutionary new strategy. They began to build protective shells around themselves to keep them safe from the harsh environment. They built survival machines. At first, these survival machines were just simple, single-celled organisms. But over the vast expanse of evolutionary time, the survival machines became more and more complex. They became plants, and insects, and fish, and dinosaurs, and mammals, and eventually, they became us. This is the first profound shift in perspective that Dawkins asks us to make. We tend to think of evolution as a story about species competing with each other, but from the gene's eye view, that's not the real story. The real story is the story of the genes themselves. We and every other living thing on this planet are the temporary vehicles, the elaborate, disposable robots that these immortal replicators have built to house and protect themselves as they journey down through the generations. You are a survival machine for your genes. This brings us to the book's provocative and famously misunderstood title. When Dawkins calls the genes selfish, he does not mean that genes are conscious, or that they have mean-spirited motives. He is using selfish as a powerful metaphor. A gene is just a piece of DNA. It has no thoughts, no feelings, no intentions. It has only one blind, unconscious property. It makes copies of itself. A successful gene is one that is good at making copies of itself. That is the only criterion that matters in the currency of evolution. Therefore, a gene will act as if it is a selfish agent, doing whatever it takes to ensure its own replication and survival into the next generation. This is a crucial point. The selfishness is happening at the level of the gene, not at the level of the individual. And the most fascinating part of Dawkins's argument is how this selfish behavior at the microscopic genetic level can give rise to a world of seemingly altruistic and cooperative behavior at the macroscopic individual level. Think about it from the gene's perspective. Your body is a colony of thousands of genes all working together. They cooperate because it is in the selfish interest of each individual gene to ensure that the survival machine they all live in, your body, survives long enough to reproduce and pass them on. Your genes are not your enemies. They are the ultimate team players locked together in a shared fate. But the most powerful examples come when we look at how we interact with others. Why does a mother bird risk her own life to protect her chicks from a predator? From the perspective of the individual, this is a purely altruistic act. But from the perspective of the gene, it is a perfectly selfish one. The mother bird is a survival machine. But her chicks are also survival machines, and they are carrying 50% of her genes. A gene for fiercely protect your children is a gene that has a very good chance of surviving into the next generation, because it is located inside the children it is protecting. So, a selfish gene builds a brain that produces the powerful and genuinely felt emotion of selfless parental love. This idea, called kin selection, explains why altruism is so common among relatives. You share, on average, 50% of your genes with your siblings and your children, 25% with your grandchildren and your nephews and nieces, and 12.5% with your first cousins. From a gene's eye perspective, a gene that programs you to help your relatives is a gene that is helping copies of itself that happen to be located in other bodies. This is the cold, mathematical logic that can explain the warmth of family loyalty. But what about altruism towards non-relatives? Why do we sometimes help strangers, even at a cost to ourselves? Dawkins explains this using the concept of reciprocal altruism. This is the simple, powerful logic of you scratch my back and I'll scratch yours. He illustrates this with a famous thought experiment from game theory called the prisoner's dilemma. Imagine two partners in crime are captured and held in separate cells. The prosecutor offers each of them a deal, and they can't communicate with each other. If you betray your partner and they stay silent, you go free and they get a long sentence. If they betray you and you stay silent, they go free, and you get the long sentence. If you both betray each other, you both get a medium sentence. But if you both stay silent and cooperate with each other, you both get a very short sentence. If you only play this game once, the most rational strategy is to betray your partner. But what happens if you play the game over and over again with the same person? In the 1980s, a political scientist named Robert Axelrod ran a computer tournament to find the best strategy for an iterated prisoner's dilemma. And the winning strategy, the one that was most successful over the long run, was a very simple one called tit for tat. The strategy is this: on the first move, you cooperate, you stay silent. On every subsequent move, you simply do whatever your opponent did on the last move. If they cooperate, you cooperate. If they betray you, you betray them back once, and then you are willing to cooperate again if they are. This simple strategy is nice. It starts by cooperating, it's retaliatory, it punishes betrayal, and it's forgiving. It's willing to cooperate again after a punishment. And it turns out that this is a perfect model for how cooperation can evolve in a world of selfish actors. A gene for tit-for-tat behavior, a gene that programs an organism to be initially helpful, to remember who has helped them in the past, and to punish those who have cheated, is a gene that will do very well over the long run. It builds a reputation for being a good cooperator, which attracts other good cooperators. This, Dawkins argues, is the genetic foundation for our complex human emotions of trust, of gratitude, of guilt, and of righteous anger. They are the psychological tools that our selfish genes have built to allow us to play the long and complex game of reciprocal altruism. In the final, and perhaps most mind-bending chapter of the book, Dawkins introduces a completely new idea, a new kind of replicator that is unique to our species. He was looking for a term to describe a unit of cultural transmission, an idea, a tune, a catchphrase, a fashion, that spreads from person to person. He wanted a word that sounded a bit like gene, and so he coined the term meme. A meme, in its original Dawkinsian sense, is a cultural replicator. It is an idea that lives in the brains of people. And just like genes, memes compete with each other for survival. They replicate themselves by leaping from brain to brain through the process of imitation. Some memes, like the idea of the wheel, are incredibly successful and spread across the entire globe. Other memes, like a silly catchphrase, might have a brief, viral flash and then go extinct. The world of cultural evolution, or memetics, follows the same basic Darwinian rules as genetic evolution. The memes that are good at getting themselves copied, because they are useful, because they are beautiful, because they are psychologically appealing, are the ones that will survive and spread. The idea of God, for example, is an incredibly successful meme. It is a complex of co-adapted ideas that has been replicating itself in human brains for thousands of years. The fashion of wearing a baseball cap backwards is another much simpler meme. This idea is profound because it suggests that there is a second, independent evolutionary process happening on our planet, one that is moving much, much faster than genetic evolution. Our human culture is a vast ecosystem of competing and cooperating memes. And this leads to the book's final and most hopeful philosophical point. For billions of years, life on Earth was at the mercy of the blind, unconscious replication of selfish genes. We are the products of that process. but we are also the first species on Earth, thanks to our big brains and our complex culture, to be able to understand that process. We are the first survival machine to be able to look at our own programming and say, I see what you're doing. And even more, we have the power to consciously choose which memes we want to cultivate and spread. We can use our foresight to rebel against the blind dictates of our selfish genes. We can build a society that is based not on the ruthless logic of kin selection, but on a universal, meme-driven altruism that extends to all human beings. We are the only creatures on Earth who can defy our own programming. As Dawkins famously writes, we alone on Earth can rebel against the tyranny of the selfish replicators. The Selfish Gene is one of the most important science books ever written because it gives us a new and powerful perspective on our place in the universe. It is a profoundly humbling idea. It tells us that we are not the pinnacle of creation, but rather temporary vessels for an ancient and immortal river of genetic information. But it is also a profoundly awe-inspiring idea. It connects us to a 4-billion-year-old story, a story of an unbroken chain of successful replication that stretches all the way back to the primordial soup. The genes that are inside you right now have survived ice ages, asteroid impacts, and countless predators. They are the winners of a planetary tournament that has been going on for eons, and for a brief and precious moment, you are the magnificent machine they have built to carry them into the future. The book is not a moral prescription. It does not say that because our genes are selfish, we are doomed to be selfish. In fact, it says the opposite. It shows us that by understanding the deep genetic roots of our behaviors, both selfish and altruistic, we can become more conscious, more free, and more responsible for the kind of world we want to create. It is a deep, challenging, and ultimately liberating inquiry into the very nature of life itself. If you are ready to see the world from this completely new and mind-bending perspective, then you are in the right place. Welcome to Geeky Philosopher. Subscribe, and let's continue to explore the big ideas that define who we are.